Ready for a little review on chapter 1? Yep, we've reached the end of chapter 1, so let's walk through these 7 little problems for review. Going back over, what is the additive inverse of negative 17? Well, we were looking for a number that when added to negative 17 makes 0. So let me get my pen going here. I'd have negative 17 plus something that equals 0. And indeed, that something would be 17. So 17 is the additive inverse. True or false? Some integers are whole numbers. Well, when I do these problems, I often think of that Venn diagram and the structure of it. And I know that integers is a larger class of numbers than whole numbers. Whole numbers, remember, are those ones that start at 1, 2, 3. Oops, they actually include 0, 0, 1, 2, 3. They are integers, aren't they? Yeah, all the whole numbers are integers. So some integers, yep, some of them are whole numbers. But then there's a whole bunch of integers that are not whole numbers, that fall outside the whole number system. So this would be true. There are some integers that are also whole numbers. Use the inequality symbols to rewrite the statement that x plus 2 is between, okay, so this is going to sit between negative 2 and 5. So I've got some betweenness going on. I'm going to kind of set that up in the middle. And then on the high end, I have 5. So that's going to go to the right. On the smaller side, I have negative 2. And now I got to come up with some sort of symbol that belongs in here, right? To do that comparison. That didn't quite do what I wanted. Okay, so I got to come up with an inequality symbol. And that inequality symbol would be negative 2. It excludes the endpoint, so I just want a less than symbol there. That x plus 2 is greater than that negative 2. And it includes negative 5, so that would be less than equal to. Yeah, that should do it. X plus 2 sits between a lower and an upper bound. Write each of the set notations in interval notation. Okay, I know what interval notation is. That's when I use parentheses, brackets, that sort of idea. And then graph the inequalities. So this says the set of x is such that x is greater than 3. As an interval, I don't want to include my endpoints, so I'm going to use an open parenthesis, 3, and it needs to get bigger because x is larger. Our numbers are bigger than 3, so it's going to look like that. Recall that you always use an open parenthesis when you're working with infinity symbols. All right, now to graph it. And on the test, we want you to graph very specifically. I tend to graph right above the number, just my habit. But it's not incorrect, and maybe some of your previous teachers taught you to put it right on there. That's fine too. I just sometimes find it hard to see the shading that you guys do. So just be sure your shading shows up nicely. Next, negative 7. X lies between negative 7 and 3. I'm going to have an endpoint included. Whoops. We're going to have an included endpoint and an excluded endpoint, it looks like. So x lies between, our numbers are between negative 7 and 3. Not included, but included, right? Shade that baby in. Shade it fully because of the greater or less than equal symbol there. And then I want everything sitting between there. Okay? Adding 2 fractions. Well, we remember when we add 2 fractions, we have to have like denominators. And in this case, I want to make 21 my like denominator. So I would take negative 4/7 and multiply it by something to get 21 correct. We're going to multiply by 3 over 3. Then we'll add this to negative 20 or negative 2 over 21. That will look like negative 12 21st. Whoops, what's up with that? Plus negative 2 21st. Two negatives make more negatives, so I'm going to have negative 14/21, which indeed can be reduced. Let's divide both by 7. So we're at negative 2/3. There's our answer. The next one I like, although it's easy to miss. This is saying we're going to square. What am I squaring? I am only squaring the thing that it sits directly next to. So that means in this case, the negative is not part of the squaring. So it's really turning into a negative 7 times 7 or negative 49. When would I have included the negative as getting squared? If I had a scenario that looked like that, where it is negative 7, all of it getting squared. Okay, so I'd have negative 7 times negative 7, positive 49 in that case. So just know the difference. Watch what's included in the squaring. And finally, 7, where we use order of operation. This is where we're doing our PEMDAS, and we want to just be sure that we're using the please excuse my Durant Sally operations. I am scanning my problem and I notice it's a fraction first up. So that means to me, I am individually going to do the top and individually process the bottom, and then I'll merge the two together. So let's go across the top. Across the top, I would get 6 in parentheses, a 1. So I'm going to have 6 times 1. I'll hold off on doing that for a moment. Addition always comes at the end. I need to multiply before I do addition. So I get a 10 there. Processing the bottom, first thing that I glanced at, I noticed there's parentheses as well as multiplication as well as subtraction. So what should come first? Grouping symbols. So let's do the 4. Leave it out there. We're going to multiply it by the 3 because I want to process the group first. Now I'm still processing my top separate. So I'm multiplying 6 times 1, that's 6. Adding 10 is 16. Bottom is 12. Reduce fractions when possible. I get 3 halves. Final answer. All right, you are primed and ready to take the test. Good luck on your Chapter 1 test. Remember, it is no calculators, so you want to be able to do all these without calculator.